Okay, so first things first. Our first line of code that gets executed is this one. So I have a value of x equals 0. Over here, I'm just going to keep track of my variables and their corresponding values in a nice little chart. So x equals 0, then we hit the try statement. Try statement says just start doing the things inside of this block. That first thing is x plus equals 1. That's an okay line of code, which means we come over here and we update our value of x to 1. The next line of code is this print x divided by 0. This line contains an error. Right? What is the error? It's this. We can't divide anything by 0. It's going to raise a 0 division error. Right? 0 division error. And remember that 0 division error is in that hierarchy underneath exception, which means it will get caught by the except clause. So remember the flow. When you hit an error, the first thing that happens is we're going to jump right to the first except in the list and find the very first one that matches in the order. This except clause is written just alone by itself, which means handle any and all errors. And so what we're going to do is execute the line of code right underneath x plus equals 20. And so the value of x shifts from 1 to 21. All right, and then we escape the try and except clause. We're done with that. That print x means that the value that gets printed is exactly 21. All right, moving on to question number 2. Same thing as before. First line of code that gets executed is this. X is equals 2468. We've got a list. Its name is x's. So x's is a list. There's 4 things in it. 2, 4, 6, 8. So next line is a try. So let's attempt the following line of code. Print x is at index 6. So there are 4 things in this list. Can't access the 6th index if there's only 4 things. So this is an error. Right? But the question is what kind of error? So this is an index error. Right? Attempting to access an index that does not exist results in exactly index error. The way that we will handle that is by following the order of these except clauses. So first except is except index error. This matches the error that was thrown in the try. So that means we're going to print A. All right, that is the line of code that gets executed there. So A gets printed. Now the question here is what else gets printed? So remember, only exactly one except clause will get executed, even if there are more than one. Only the very first one that matches. So because we found one that matches, we will skip that second except clause to go down to this last print statement after the try and except, meaning that we're going to print C, and that's our final answer. We print A, C next to each other. For this question, we're asked to indicate which exception will be raised given the following expressions. This first expression, int with the string 3.4 passed into that function. The int function attempts to turn its argument into an integer. Now, the question here is, what error, if any, happens? This will be an error because we do not know how to turn the string 3.4 into an integer. Now, this might be a little confusing because if you were to do this, int 3.4, without the quotation marks, that would not give you an error. It will just truncate the decimal, turning the floating point number into an integer. However, pay close attention to the fact that we have a string passed to this function. This string contains a period, and this period throws off the int function's calculation to turning this string into an integer. Okay, we only know how to do strings with exactly digits in them, without any other characters. So that means we know an error will be thrown here, but which one? When I pass a function a correct type of information that it knows how to work with, so the string in this case, we will not be throwing a type error. It knows how to turn strings into integers. The problem here is with the value of this particular type. I've given the int function a bad value, the string 3.4. That means the value error is what gets raised, or b. For this next one, int with the list 2, 3, and 4, this time the int function just straight up doesn't know how to turn a list into an integer. So if I pass in this bad type to the int function, I'm going to get a type error because the int function doesn't know how to work with a list. That means this answer is A. The key to number 5 is understanding the order at which expressions will be executed. So we have a print function, and inside this print function we have 3 different arguments given. Now each of these 3 expressions has an error inside of them. Right? Each of these 3 expressions has an error that is listed in this box. And so we can't possibly say all of them. We have to determine exactly which one. Remember, the order at which expressions get computed in Python will go from left to right as I look at the arguments to this function. So the very first expression that gets executed is this one, the list 1, 2, 3. Let's grab the thing at index 15. Well, this list has exactly 3 things in it. There's no 15th element. So what kind of error is that? That's an index error. Right? Giving a bad index to a list. So for number 6, you just have to dissect the expression. Here we have a dictionary, and on this dictionary, we're calling the .get method. So recall the .get method will take 2 arguments. Okay, one is a key, and the other is a error value. Okay, so if this key does not exist in the dictionary upon which you call .get, then return the error value. Otherwise, the key does exist, so just return the value associated with that key in the particular dictionary. This means that if we look at our setup over here, we're going to take the number 5 and look for it as one of the keys in the dictionary. Only keys are 3 and 1. 5 is not one of those keys, which means we're going to return the number 6. At no point did an error happen in any of that. Right? This whole expression just condenses down to 6. So there was no error in this particular question, so the answer is F. So let's make a pie. Our pie class starts off like this. We must be able to construct pies with both a flavor and a number of slices. Okay, so that means our init method, or our constructor, should look like this. Self is always the first argument, parameter. Then we have a flavors, our flavor that gets passed in. Then we have a number of slices as well. So remember, we should default this to 8 should it not be provided. So how do we store this information? We go inside of this self, we create a flavor attribute, and we store the value of flavor that got passed in to this constructor. We do the same thing for num slices. And that's the constructor. Okay, so I made the class a little bit smaller so I had room over here to keep writing. So now let's build the str method. Remember the double underscore str self. What this does is it tells Python how to turn this object into a string. Right, whenever I call the str function on a Py object. Let's just build a string that looks like this. Take our flavor, followed by some extra characters, and our num slices as well. So let's do Let's build our format string first. So fmt str. I'm going to set that equal to something. The first part of this string is a placeholder. It's some data that will change. So I need just to reserve some spot for it. Then there is a left parenthesis. And there's some more data that will change. That's going to be our num slices. And then there's some filler characters, slices left, followed by a right paren, and close our string. So our format string is two placeholders for data that needs to get filled in, and then some extra characters that are just always a part of these strings. So how do I actually generate the correct string? Our result of the str function is taking this format string and actually formatting it with the relevant data. So first part is going to fill the first placeholder. So that should be our flavor. We access that via self.flavor. And the second part should be our number of slices. We access that with self.numSlices. And so there is the full str. Many different ways to write the string function. This is just one of them. And now for this last method, getSlice. We should remove one slice if there's slice is present, and return true if we were able to remove a slice. Otherwise, return false. So our method called getSlice. It's a method. It should have a self parameter. It doesn't need anything else because everything we care about is contained within self. The num slices in particular. So what does that mean for this particular object? Let's first check if we have enough slices. So if inside of myself, my slices, if that is less than or equal to 0, that means I can't remove slices. I don't have any left. I should return false. I'm not able to remove slices. Right? Otherwise, right, else, let's go ahead and take one slice away. So on my slices, let's subtract 1 and store that back in the same place, and then return true to signify that we have successfully removed a slice from this pie. So how do I make a pie? Well, we create a variable. I'll call it myPie. We invoke the constructor by naming the class and putting parentheses to say, here's the flavor of pie as the first argument, and here's the number of slices that this pie has. Then we should print, we should get at least one slice. So in my pie object that I make, I call the method getSlice. Remember, we do not have to put anything in here. Right? Self is taken care of by Python. Anything after self, you'd have to include an argument for. Then print the pie. So print the pie could be something like this. Print str myPie. And what will be printed here? The string version of this pie, which will be apple, with 6 slices left because we would have just removed 1.